The question says, if the angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base and in the same straight line with it are complementary. And what do you mean by complementary angles? That is, if two angles, say theta 1 and theta 2, are complementary, then theta 1 plus theta 2 will be equal to 90 degrees, right? So it is said that through both the points the angles are complementary. So now we need to find the height of the tower. So first of all, said, like this question is of heights and distances. So first of all, we need to draw a rough sketch of what we can imagine here, right? So let us say that this is our ground level and this is the tower. This is a rough sketch of the tower that we are talking about, right? So let me share this for you. Okay, fine. So we have this tower in front of us. Now it says that from a distance of 4 meters and 9 meters. So what I'll do, I'll just take a distance of 4 meters and let's say this distance is 9 meters. So now let us name the points A, B. AB is our tower. This is C, this is D. So now we have here that BC, this is 4 meters, and BD, this is equal to 9 meters. And it is also said that the angles of elevation, basically they are complementary. So if let us say that this angle is theta, right, and say this angle is some angle phi, so I know that if they are complementary, then theta plus phi will be equal to 90 degrees. From here I can write phi is equal to 90 degrees minus theta, right? So this I can write it as is equal to 90 minus theta. Fine. So now let us assume that this height of this tower is h meters. So now the question is find the height of the tower. So it's a pretty simple question. So what we'll do, we have triangles in triangle ACB, right? In triangle ACB, let us write down the value of basically tan theta. So from here I can write tan theta is equal to h divided by 4, and which gives me h is equal to 4 tan theta, right? This is the first equation that I got. Now consider the second triangle. That is in triangle ABD, the bigger triangle. In the bigger triangle, I can see that tan of phi, that is tan of this angle, is equal to h divided by this complete distance BD, which is nothing but equal to 9. So from here I can write h is equal to 9 tan phi. Now you can see that from equation 1 and 2, both are the values of h itself. So therefore, equating the values of h from equation 1 and 2, let us see what we'll be getting here. So 4 tan theta is equal to 9 tan phi. Now you know that phi is nothing but 90 minus theta. So this gives us 4 tan theta is equal to 9 times tan of 90 minus theta. And according to the concept of complementary angles, I can say 4 tan theta is equal to 9 times, now tan of 90 minus theta is nothing but cot of theta, right? So this gives us 4 tan theta is equal to 9 upon tan theta, right? Because cot theta is nothing but 1 upon tan theta. So finally I can write it from here that tan square theta is nothing but equal to 9 by 4, and therefore tan theta is equal to 3 by 2, right? So now our tan theta is equal to 3 by 2. In the question we need to find h. Now what is h basically? 4 times tan theta, right? So 4 times tan theta, I'll just one more step and finally we'll be having here, therefore h is equal to 4 tan theta, which is nothing but equal to 4 into 3 by 2, 2 to cancel, which is equal to 6 meters, which is our final answer.